Hello, good evening, guys.
Good evening, sir.
Good evening, good evening.
Good evening, sir.
Enjoyed the long weekend again?
Yes.
Okay, cool. Are you all back to the mode of coding? Okay, shall we wait for 2 minutes? Wait for 2 minutes, or by the time, if you have any questions, can ask me any questions regarding any topic till we have covered. No questions? Did the previous lab, the first lab, collections 1?
Yes, sir.
Okay. Okay, cool. Okay, shall we begin?
Yes.
Let me share my screen. Have you all gone through the linked list topic in the collection, that video in the portal?
Yes, sir.
Hello, everybody. I hear only one voice.
No, sir. Not yet.
Not yet. Implementation of linked list and those videos haven't yet gone through.
Yes, sir. Not yet.
Okay. Anybody else? I was thinking of recapping that particular thing, means how to implement our own linked list. Have you all implemented the stack using arrays? There was a question in one of the lab, implementing stack using arrays.
Yes, sir. I completed.
Cool. Guys, others, do you know what is stack? Stack. Push, pop.
Yes, sir.
Okay, cool. Okay. So today we will see how to implement our own linked list as we have implemented stack. Okay. Before that, we'll have some knowledge about linked list, what is linked list, how it works, and then we'll see how Java has implemented its own linked list by using what data structure and what are all the methods that we have inside that linked list class. Okay.
Yes.
Let me share my screen. Can you see my screen?
Yes, sir.
Yes, sir.
First of all, what is linked list? It is a
Data structure.
data structure. Linked list is a data structure, means it offers a kind of a way to store data in a specific manner. Okay. And it is a linear data structure. Okay. So that means we will store the elements in this data structure one after the another. Then linked list elements are not stored at contiguous location. Okay, even though we store one after the other elements in this data structure, but when we consider or when we see it in the viewpoint of memory, it is not stored at the contiguous location of the memory, like one after the other, as we had in which data structure?
Arrays.
Array elements were stored contiguously one after the other. So, but this linked list elements are not stored contiguously in the memory, but the elements are linked using pointers. You create one element here somewhere in the memory, and you create one more element after some time or immediately. It might be come into that contiguous memory, but we do not know. But always these linked lists are or the data in the linked list is connected, is chained with pointers. Okay, and all the linked lists contains nodes. Each and every data point is called as nodes of linked list. Okay, one data point is connected to another data point, and that is connected to another data point. These data points are called as nodes in the linked list, and each and every node has data and pointers to other nodes. Okay, we have a node, we have pointer to another node which has the reference to that node, and that node has some data and pointer to another node. If it is a singly linked list, it will flow like this from first to last node. If it is a doubly linked list, it will have two pointers pointing to forward node and backward node. Okay, and it maintains the order of insertion. Okay, we have some of the linear data structures like arrays, lists, and stacks. In arrays, in lists, we have array list and we have linked list. Okay, and array list offers contiguous storage of data, and this way of storing data offers some advantage like random access and easy retrieval. Okay, but linked list, since it doesn't allows a contiguous storage of data, it doesn't support random access. We cannot access any element of the linked list using some index value or something like that. It's not possible in the linked list, but there are some advantages. It is the disadvantage of using linked list. If at all you are using some data structure where that should provide the random access, then you should not use linked list. You should use array list. If you want to easily insert and delete data between the nodes in between, why can't we do this using arrays? What is the disadvantage of arrays?
You need to shift the elements to.
Yeah, if you want to add an element to an index, you need to empty that space and shift all the moving forward further elements to one box next to that particular index. Okay, it takes so much of time and memory also, like you are indefinite that how much memory you have in, or yeah, whether you have the next memory or not, if some data loss may occur. So many things are there to be considered, but when it comes to random access, you should always use array list. When it comes to easily insert and delete some of the nodes, some of the data from the data structure, you should always choose linked list. Clear? This is an important interview question. What is the difference between array list and linked list? Why should we choose one upon the other? Okay, both are best in its own way, but both has its own advantage and its own disadvantage. Clear?
Yes, sir.
Any questions? What do we do with data? Yeah.
So just to clarify, in situations where I want something which will not have multiple insertions and deletions, I need to use arrays and array list. And then where I need to keep adding data and removing data, I need to use linked list.
Yeah. Correct. Correct. Good. So what do we do with data? What do we do with data? We do
Third operation.
third operation. We have to create data, read data, update data, and delete data. And we will see how do we do this by implementing our own linked list. Just to show you the what somewhat a kind of pictorial representation. Can you see this?
Yes, sir.
Okay. So every linked list has a node and it will have data. Each and every node have data. This is just a singly linked list node. Okay. We will implement singly linked list today. So every linked list will have data and pointer to the next node. Okay. That means what? What should we implement node as?
A concrete class.
Concrete class having what?
Data and next nodes reference.
Yeah, data and next node implemented as what members?
Instance member.
Instance variable.
Variables.
Okay. So what is the data type of data?
So you should tell me. I don't know.
Yeah, you should ask for example values. What kind of linked list or what kind of data are you going to store in this linked list? Think I want to store integer data for this implementation. Then it will be
Int.
int. Correct. Good. What will be the data type of next node?
Nodes.
Exactly. Correct. Good. It is of data type node. It is there. It is a reference data type. What it will contain? The reference of next node, the address of next node. So its data type is node. Understood? Understood this? Any doubts?
No, sir.
Okay, that's what I have written here somewhere. So we have node class and we have data, which is of data type int, and we have next, which is a pointer to the next node and its data type is node, and we have position. Okay, current node's position we have to hold. This is at the position 0. This is at the position 1, 2, 3. For that, I am holding this particular long variable called position. Okay, this is the representation of node class. So we'll just see that node class also so that that becomes clear. So to create a node in a linked list, one data point in a linked list, we have to create one node class having pointer to next node and data which holds data. It can be of any type depending on what data that we need to hold in our linked list. Okay. Then we have position to hold the position value of, or you may think as it is as a index value. Okay. Then we have a constructor which accepts data and position. Okay, and this dot data equal to data. We need not do any validation here because we will store all the data, all the integer valid int value as data. Okay, and if position greater than or equal to 0, then this dot position equal to position. Okay, else if the position is 0 itself, let it be that one. Okay, then we have setters and getters for data, next, and position, and we have a toString to represent this node with its data and position. Any doubts in this node class? Hello,
No, sir.
everybody clear?
So far, yes, sir.
Okay, we have three data or three instance variables. I'll just recap. One, to hold the reference of the next node, another to hold the data, and the third one to hold the position value. Okay, then we have a constructor through which we will create the node object. Then we have setters, getters, set next, set data, set position, and get next, get data, and get position. And we have a overridden toString method to represent this node in the string format, which tells about the data and position. Okay, this is it about this node class. Clear?
Yes, sir.
Okay, cool. Then we'll go back here. So how does a linked list is represented? You see, a simple singly linked list is represented like this. We have node 1, 2, 3, 4, 5 like this. We'll have nodes like this, and each node contains data here, not here, pictorially here. Okay, data and a reference to the next node. Okay, so this reference is holding the address of next node. This reference is holding the address of node 3. This reference is holding the address of node 4. This reference is holding the address of node 5. At last, this is the last node. The address of the next node will be pointing to null. Whenever, while we are traversing any linked list, once we find the address of the next node to be null, then we are sure that that is the last node of the singly linked list, or even doubly linked list also. The last nodes next will be null. Okay, so the first node is called as head node. The last node is called as last node. Okay, each and every linked list will have this head node and last node. Okay, a question to you. If there are no elements in the linked list, what will be the value of head and last node?
Can you repeat the question?
If there are no nodes in a linked list, what will be the value of head and last node?
Null.
Null, correct. Good. That means a linked list will have what? Will have only head node and last node as its data members. Okay. Only with these two data members will play around with huge data. We'll see how to do that. Okay. We'll have information about only two nodes. That is why the random access is difficult here. Okay. If we want to traverse to the node 3, we should go from the head node, jump to node 2, jump to node 3, then we will get the node 3. Okay. So that is why the random access is difficult in or not possible in linked list. But insertion and deletion is very easy. We'll see how to do that. Okay. And another question to you. If we have only one node in the linked list, what will be the value of head and last node? Did you get my question? Hello?
Yes, sir.
What will be the answer? What is the answer?
The same value.
What value?
The starting address of the head or last node.
Correct. That means even head and last points to only one node. When head and last points to one node, you can tell that this linked list has only one node. Okay. When they point to different nodes, then you can tell there are multiple nodes. If both of them point to null, then you can tell that this linked list is empty. Clear?
Yes, sir.
Okay, cool. So this is adding element at the last. I think I do not have adding element at the first. So you think first, whenever we create a linked list, will not have any nodes. Then for the first time, when we are adding any node, then head and last node will be pointing to null or have the null values. We will create a node with the data and position 0, or if it should start from 0, or 1 if it should start from 1, and point or hold that reference of node 1 both in head and last node. Okay, shall we see the implementation? Before that, we'll see what and all the members that we should have in this linked list class. Okay, we'll have singly linked list class. It will have the head node, okay, last node, and the size. Okay, these three are the data members or the instance variables that we should have in singly linked list. What are all the methods that we should provide for our singly linked list to function or expose a complete behavior? We should provide add, insert, add, and we need to receive data and we need not return anything. Insert, to insert we should receive position, which is of int, and also data, which is int. Okay, so to remove, we need the position. We'll receive the position int and return the node. And we need to search, so we'll do contains operation and we will get the data and see whether that data is there or not in the complete linked list and return boolean, true or false, and will return size and will return is empty and get element. We need the element, we need the data by passing the position. So we'll do get element and we want to print the whole linked list, we'll print the whole linked list. Okay. So these are all the methods or behaviors that we need to code for a singly linked list to work properly. And these are all the instance variables that we need to have for a singly linked list. Clear?
Yes, sir.
Okay, we'll go for the implementation and see. So we have head, we have last. Head refers to the first node, last refers to the last node. If there are no nodes, both head and last will have null as value. If there is only one node, both head and last will be pointing to same first node. Okay, then we will have a size. So now we need to add a node to the linked list. Okay, at first we do not have any nodes, thinking that we should code for that. Okay, we'll create a node object. So to add, we will not receive node. We should not add node to the linked list. Okay, we should receive data and create node out of that data and add that node to the linked list internally. Okay, we should not ask user to create node and pass that node to add. Okay, we should receive just data from the user, create node out of that data and add that node to the linked list. Okay, so we are creating node object with int data as a state and size as position value. Okay, so currently what is the size? In the beginning by default
0.
0. Okay, so when you create the node as when you create the first node, so size will be 0 and data will be the data that is passed by the user, and we'll create a new node using this constructor of node class. Clear?
Yes, sir.
Okay. Secondly, you should check whether head and last are pointing to null. Means if is this the first node we are adding to the linked list. Then if it is the first element, we have to add it or make head and last point to that new node. Clear? I'm asking this step by step whether it is clear or not. Because moving forward, you will get confused. We'll create new node, check whether it is the every time to add, you call the same method. Okay. If it is the first node that we are adding, then we have to check whether head is null and last is null. If both are null, then both should point to same new node. Means there is only one node, that is the head and that is the last. Clear?
Sir, can you scroll up a little bit to show the instance variables?
Yeah.
Okay.
That's it.
So, but in line 13, where are you mentioning that the next node of head is last and those things?
How many nodes have you added?
Only one.
Only one. So you have head, you have last. Okay. Head should point to which node?
The new one.
First node
First
that
node.
is added. Okay. Which is the last node?
The same.
First node itself is the last node. If both are pointing to null, means both doesn't have any value, then you tell both head and first point to same node. So, okay, it's like a pointer, it moves on. Okay, but head doesn't move, last move. Whenever you add the next node, the last keep moving, but head is always fixed. Okay, so we'll see that.
Okay.
So if it is not the first node, if there is already there are some nodes already in the linked list, we need to add extra node. Then head will not be null. Okay, head will never be null if there are nodes. Then if this is false, it comes here. It tells last dot set next of new node. And last equal to new node. Can you imagine this? Just show this here. I think this will help. You see, you have node 4, okay? And you have node 5. Or shall I do this? Yeah, I'll just show it here. Okay, you create a new node. If it is first node, what happens? If it is first node, think that there are 2 pointers, head pointer and last pointer. Okay, both the pointers point to the first node. This is clear?
Yes.
If it is first node. So there is already node 1. Okay. Now, just now you have added node 1. Okay. Now, where head is pointing to?
Node 1.
Yeah. Head pointer and just a minute. We just lost. Okay. You have created node 1. Sorry. What's happening? Give me a second. Right. My system is not working properly. Head is pointing to node 1 and last is pointing to where?
Node 1.
Node 1. Okay. Next, you will create one more node. Okay. Means you call add method and pass data. We will create one more node with data and position. Okay. So you come here, come to the code. Where is the code? Here is the code. Okay. Head equal to last equal to new node and the size increases, size becomes 1. You create one more node with data equal to some node 2 and node 2 data and size equal to 1. Okay. Now it comes here. Is head pointing to null?
No.
No. Second time, no, the head is not pointing to null. That itself is sufficient to not execute this if block. It comes to else block. Now what happens? Last dot set next is of new node. Means what? Now last will point to where?
Next node.
Which node?
The node 2.
Last points to okay. So we have head pointer, we have last pointer, and we will also have this next pointer. Okay. For this, next pointer is still null. Okay. You come here. Sorry. My system is really. When we create the first node, we will not tell anything about next of that first node, correct? We are not creating the next of first node. What are we creating? For the first node, we create that node using data and size. We'll go to node class. Guys, be careful. This is a bit confusing. We'll create data and we'll create position of the first node. We will keep this next node null itself until and unless we will add the next node. Okay. When we add the next node, then we'll come back here. Then we will tell now where earlier the last pointer was pointing to. It was pointing to node 1, right? For the first time when you create, it will be null. When you create node 2, okay, you point this last pointer okay. You set the last pointer dot next to node 2. Okay, you can just have this as node 2. Got it?
Yes, sir.
That means where the last pointer is pointing now, node 1. Okay, or you can okay, it is pointing to node 1, and you tell node 1's next should be set to node 2. Then you will change the last pointer to node 2. Got it?
Yes.
Head will never change. Last will keep changing. Okay, now you add node 3. You add node 3. Now what we should do first? What we should do first? We will tell node 2's next pointer should be node 3, and last pointer should become, or last pointer should point to node 3. Got it?
Yes, sir.
Any doubts? Hello? Then, where is that? You have node 4, okay, pointing to node 5. And this is the last node, which is pointing to null, okay? But now you want to add an element at the last. How you do that? You just repoint that to new node. That's it. Last node dot next node equal to new node. So if it is a first node, head node and last node should be pointing to new node. What else image I have? Adding element at the position. Okay. Inserting, that is removing element. Guys, everybody clear with the add element? Any doubts here? Did I explain properly?
Sir, can you
Just-
show me the set next method, sir?
Okay. It is in which class? Node class. Set next will receive the next node and point it to the next.
Clear, sir.
Here we should do some validation of null check and all, and throw exception and everything should be done. Okay, we'll go here. I'll recap this. Whenever user wants to add an element or data to a linked list, he will call this add method and pass data. Okay. Using that data, we have to create node. Okay, we'll create that node with data and the position of that particular node using this size attribute of our singly linked list class. Then we have to check whether it is the first node or not. If it is first node, then both head and last will be pointing to null. If both are pointing to null, we will make both head and last pointer to point to that new node. If it is not the first node that needs to be added to the linked list, then we will tell the last pointers next should be set to new node. Okay. If there was only one node, now we are adding another node. You see head is pointing to first node, then the last should be made to point to the second node. Okay. And also the last next, this you got clear. Only thing is, what is this? Last dot set next. Earlier, where the last was pointing to the first node. Okay. If this is confusing, no, it cannot be done like that, because head will be Consider this last for the first time to be head. Okay. Heads next will be set to the new node. Okay. Otherwise, if it is not the head, you think like there is an element at last. Okay. That last next should be set to new node. And last node also should be set to new node. Got it?
Yes, sir.
Any doubts? Anybody? No doubts?
No, sir.
Okay, good. Now we have insert method. Okay. So we have position. Guys, this is an important interview question. They will ask you to implement your own singly linked list or doubly linked list. Most of the time this question has come. Please concentrate. Okay. If you have any doubts, any time, even in the beginning, I myself struggled to understand these. What is last dot set next new node, last equal to new node, same thing repeats. It's like getting looped into something. Okay. But if you just imagine what's happening, there was a last node and you need to add a new node. Okay. This last node's next, the previous last node's next should be pointing to new node, and the last pointer should point to new node. That is it. Okay. Like, I'll just explain. I'm not getting satisfaction. You see? So last pointer is pointing to this node. Okay. Now this last node's next before adding the new node was pointing to null. Okay. This last node's next should point to new node. That is what this line of code is doing. Last node's next should be new node, and last node should last pointer should point to where? The new node. Now this new node should become the last node and its next should point to none. This is it. Now clear? Please give me some response.
Yes, sir.
Yes, sir.
Good.
Pointing to a new node, the last should point to new node so that its last is pointing to null.
Yes. Earlier, before adding this new node, it was pointing to node 5 and its next was pointing to null. Okay. So now you should make that its next means the last node's next should point to new node and last also should point to new node. That is it. Got it? And the last next should point to null. That is what it is here. Last's next is pointing to new node. Last is also pointing to new node. Clear? Okay. We'll just see about insertion. So we need to insert a data to the position. Okay. So if position is 0, that means we need to insert it to the first position. We need to insert it as the head node. What we will do? We will make that node to be inserted, next node to be head, and head pointing to that node to be inserted. Got it? We should not do first head node. We should not replace the head node first to the node to be inserted. If that is done, then there is nothing inside this node to be inserted next. Then you will lose the link. Okay, that is, links are very much important in linked list. Okay, you should never lose the link. First, you should make this, you should create the node that needs to be inserted, and that's next should point to head, okay, or the first node. And then head pointer should point to node to be inserted. Okay, this is what we should do. We'll see it in the code. If it is not 0, okay, if it is some n position, okay, then what we should do, first we should make this node to be inserted next to point to the next node of that position where it needs to be inserted. Then we should remove this link and make this previous node to point to this node to be inserted. Clear?
Yes.
Sir, can I explain?
Yeah. I'll explain this again. You have a node that needs to be inserted and it's next. For that, first you need to traverse through the linked list to find the position. Okay. In that position, you should add the next address first to the next of the node to be inserted before removing the link of this. Node 2 and node 3 are linked now. Okay. But before removing this link, to get this node, this particular node to be inserted here, you need to remove this link. Agree?
Yes,
But
Sir.
before removing
Yes,
this
sir.
link, you need to copy this link to this next. Okay. Now it is pointing to node 3. Now the link is there from here, and then you will add the node to be inserted link to node. Clear? Got this logic?
Yes, sir.
We'll see the code. Is the logic or the imagination of this thing should be very clear. Otherwise, you will get confused. First, see this image. Are you able to make some sense? Then we will go for coding. Is this clear? Of relinking of nodes? Okay. I hope this is clear. We'll see. So we need to create a new node with data and position that needs to be inserted with this data. Okay. We'll get the position and data in. So we'll create that and we'll create a temporary variable to hold head. Okay. First, to hold the reference of first node. Check if position is 0. Then insert it into first position. As I told, if position is 0, what we should do? First, we should copy the head to the node to be inserted next. Okay. Then we will make head to point node to be inserted. Clear? Head node's position is 0 and node to be inserted position is also 0. So what you should do? Node to be inserted set next to be temp. Clear? Then head will point to the node to be inserted. Just 2 lines of code. If you are able to understand, I'll move next. Otherwise, please ask questions. Hello?
Sir, node
Yeah.
2 ಅಲ್ಲಿ insert ಮಾಡ್ಬೇಕಂದ್ರೆ ಹೇಗೆ ಮಾಡಿ?
We'll go to that. If we want to insert it into some position, we'll go to that. If position is 0, then it will be inserted as first node. How are we going to achieve that? We will copy the head's address to the next of the node to be inserted and then point head to the node to be inserted. Clear? And we have some reposition kind of method. It will, if we inserted it, it will just reposition or make the position value to be correct once we insert it. Shall we see that method first before going forward, or shall we complete this method?
So complete this and then go there.
Okay, good. If position is not equal to 0, if it is some n number, if it is 2 or 4 or 10, anything, how do we insert it? Okay. While temp dot get position is less than position minus 1. What are we doing here? Can anybody guess or tell?
Traversing the list.
Yes, we are traversing the list, linked list, by getting the or replacing the temp's value. We start from the head. Temp is nothing but head, while temp dot get position is less than position minus 1. Means if we want to insert the insert node at position 3, we should traverse to position 2, as we have here. If we want to insert position at 3, we need to traverse till 2. Okay, so that is why position minus 1. Until temp dot get position is less than position minus 1, we will keep replacing this temp equal to temp dot get next, temp equal to temp dot get next. Okay, then at last what we should do is we should make temp as the third node. We should copy the temps next to the node to be inserted, and that will make that node to be inserted as node 3. Okay, node to be inserted set next will be temp dot get next, and temp dot set next. I'll just shall I do this? You can see here. Can you see this? You consider first, for the first iteration, if position is not equal to 0, then temp is equal to head. Means that is what is node 1. Okay, temp is pointing to node 1. While temp dot get position is less than position minus 1, you keep doing temp equal to temp dot get next. Okay, that means at the end of this while loop, temp will be pointing to which node?
2.
Node 2. Okay, and we have a node to be inserted. Okay, this node to be inserted next, node to be inserted dot set next should be set to what? Temp is pointing to node 2, temp dot get next. Means this next pointer's value will be copied to the next pointer value of node to be inserted. Clear?
So,
and that is pointing to node 3. Now, what we should do is, now we have the link here to the node 3, and we have this node that is created newly. Now we are able to unlink this and link to this. If we link to this, this will have link to this. Now it will form a perfect linked list. Okay, how do we do that? We'll do that. Temp dot set next is node to be inserted. Okay, means temp was pointing to node 2. Its next was pointing to node 3. Now we will derefer that, and temp dot set next will be set to node to be inserted. Clear? And we will call reposition and it will reposition all the thing, and this will come and sit here as the node 3. Clear? Is it clear?
Yes, sir.
Yes,
Any
sir.
doubt? Any question? If you have not understood, please ask again. I will repeat again. Clear?
Yes, sir.
Okay, cool. Now we have remove method. Okay, this works same. Just shall we see reposition first, then we'll come to remove.
Okay, sir.
We have reposition and we have new position equal to 0. If head not equal to null, means if our linked list has some elements. If it is not a empty linked list, then only we'll do all these operation. What we do, same temp operation, same traversing, node temp equal to head, while temp not equal to null. When will you get temp equal to null?
It is equal to none.
When we reach the last node. Okay, temp dot set position of new position plus plus. Okay, we start from 0, we start from head, and we'll set the position and tell new position and make this pointer to move to the next node. Okay, temp equal to temp dot get next. We'll go to first node. Temp is pointing to head, and position, set position equal to 0. Okay, then temp equal to temp dot get next, means it points to node 2. Then set position equal to 1. Then temp equal to temp dot get next comes and points to node 3, and set the position to 2. Temp equal to what? Node 4. Means temp equal to temp dot get next, means it points to node 4. Set position to 3. Now temp equal to get next. What is get next? What is get next?
None.
Null. If temp is null, then come out of this while loop, and then that repositions every node to be perfect with its position values. That's it. If it is an empty linked list, you just SOP the linked list is empty. Clear with this reposition? More than this, you should be very clear. You should have been very clear by now that how to traverse a linked list. Clear?
Yes, sir.
Okay, cool. So is empty. If size is equal to 0, will return true, else will return false. And to get the size, we'll return the size. Okay, so to print, we'll see. This is as same as reposition. We'll see how to print any linked list. If head is null, then we tell linked list is empty. If head is not null, we'll create a temp node. While temp not equal to null, keep printing the data of the that particular node, and tell temp equal to temp dot get next. Clear? This is how you print the linked list. Okay, then you come again here. I'm seeing people dropping off. Can't help it. It's a bit complicated problem, but the data structures are complicated. Many cannot help it, because you should have some mental imagination how this data structure works. How much ever I may explain or anybody may explain, you should think how the data is getting manipulated. The link is getting manipulated, link is getting copied. Thinking pictorially helps you thinking programmatically. Okay, you create nodes with data and next variables. Now you think node 2 is here. I need another node to be inserted, and node 2 is pointing to node 3. If once for all I point node 2 to the new node that is to be inserted, I lose the link to node 3. That is why what I should do is I should copy the next pointer of this node 2 to the next pointer of node to be inserted. Now that points to new node, that points to node 3. And just now I have created this new node and I have copied the next of node 2 by traversing till that position, and I have come to know the position value. Just give me a second. Sorry, got distracted. So node 2 is there, and I have come to node 2 by traversing, and node 2's next I have copied to this, and this reference also I have because just now I have created. The next link also I have. Now I am safe to relink or dereference this particular link from the linked list and point to new. Now the chain is complete. That is how it works. This kind of this thing you should have. So how do you achieve it in code? Node 2's next means temp's next should be copied to node to be inserted. Means node to be inserted dot set next of node 2's next. Okay, then you tell that node 2's next is equal to node to be inserted. That's it. This is how you should think. Okay, then get element also will come. Get element will so we will give the position to get the element. We should get that node to or we should return that node of that particular position. We will just return element is equal to null, which is of node, and we'll tell if head not equal to null and position is less than size minus 1. We cannot find the 100th positions node, or we cannot return 100 position node if we just have 50 nodes. Okay, that is why we should check for both of these conditions. If head not equal to null and position is less than size number 1, size minus 1, then node temp equal to head, while temp not equal to null, you traverse it and you keep getting up to that position and return what? temp equal to temp dot get next. Then what is there? Return element equal to lost. If position is equal to minus 1, you keep doing this and tell return element equal to temp if the get position of the temp equal to position. Clear? I'll explain again. If head not equal to null means linked list should have some elements, then position is less than size minus 1 means the given position that for a node to be returned should be less than the length of the linked list or size of the linked list. Then we will traverse the linked list using that temp method, while temp not equal to null. If temp dot get position equal to position, then return element equal to temp and tell that temp equal to temp dot get next. It keeps traversing until and unless this get position we get, and we can break out from here. We can break. Okay. It breaks out. Else if head not equal to null and position is size -1 means he is requesting for the last element. For that, we know we have readily head element, we have readily last element. Okay, if that is the case, then we will tell last, return element equal to last. Else we tell that linked list is empty, and we will return the return element. Clear?
Yes.
Any questions? Any doubts? Okay, good. Then we have contains. We have to search for given data. Okay, we will have does contain equal to false, head not equal to null, keep traversing and check whether temp.get data equal to data. If it is true, then does contain equal to true and break out from this. Okay, then else SOP, the linked list is empty. That's it. Clear? Is this clear? Should I explain this even? While temp not equal to null, you are traversing by doing temp equal to temp.get next. If temp.get data becomes equals to data that is passed, then does contain equal to true and break out and return that does contain. If head itself is null, then there are no elements in linked list, then return false, because the value that is assigned is false. Clear?
Yes.
Okay. Everybody clear? Okay. I think it's clear. I assume. What can I do? Then we have remove. Okay. We have to remove a node from the position. Okay. So after removing, we have to return that removed node. For that, I'm creating a reference removed node, which is equal to null. Now, to traverse, we will have a temp that is equal to head, and never ever operate on head, guys. If you lose head, everything is lost. Okay. In linked list, both head and tail, means head and last pointers are very important, and all the pointers are very important. Be careful before you dereference any pointers. Okay. Then we have to check if position is equal to 0. Then we have to remove what? Which node? We have to remove which node? Head node. First node we have to remove. I think I have that. Yeah. Can you see this? See, if you want to, if position is equal to 0, then you have to remove the first node. How can you do that? Very easy. You point head node to the which node? Head nodes next. Okay. Removed node equal to head means first you should get that node, then head equal to head dot get next, and you call reposition. Clear? This is the removed node. This reference you keep in the removed nodes reference like this. Okay, by doing removed node equal to head. Then head equal to head dot next, which is the second node. Now removed node contains this reference and head node contains this reference. Now this is removed or delinked from the linked list. Got it?
Yes.
One question, have you observed, is it completely delinked?
You have to change the position value.
Yeah, for that we are doing reposition.
Yes, so it's completely delinked, isn't it?
What does removed nodes next contain?
It contains head dot get next.
Dot next.
It contains removed nodes. Removed node contains what? Next.
Next value.
Next of this means it is also pointing to this. For that, you should do removed node dot next equal to null. Got it? Then it gets completely delinked from the linked list.
Clear, sir.
Okay. There are so many linked lists. There are doubly linked list. There are circular linked list. There are one node having so many linked to so many nodes. Like that, you have so many linked lists. Okay, there are so many kinds of linked list. Will not sir ಒಂದೇ ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ. Okay, cool. We'll not think about much about that. So if you want to completely derefer, you have to make this removed node dot next equal to null. So else, if it is not the first node that needs to be removed, then what we should do? Then we'll traverse till that position. Okay, temp dot get position less than position minus 1 and temp equal to temp dot get next. And we'll do this removed node equal to temp dot get next. Okay, so we'll move up to that position. Means if you want to remove third node, we'll move up to second node. Okay, I think I have this. You see, I want to remove this third node, so I traverse till second node and copy removed node, the temp dot next. Okay, the temp dot get next. Temp is pointing to node 2. Temp dot get next will be what? The removed node. Okay, this node 3 will be copied to removed node, and then temp dot set next will be set to removed node dot get next, and temp dot get next dot set next to null. ಏನ್ ಸರ್ ಸೆಟ್ ನೆಕ್ಸ್ಟ್ ಗೆಟ್ ನೆಕ್ಸ್ಟ್ ಏನೋ ಅರ್ಥ ಆಗ್ತಿಲ್ವಲ್ಲ ಅನ್ಕೋಬೇಡಿ. I'll just reiterate or recap this, repeat this. We will traverse till node 2 to remove node 3. Got it? Got it? Hello?
Yes, sir.
Yes, sir.
Will traverse till node 2 to remove node 3. We should traverse till node 3 to remove node 4. Okay, so temp is pointing to node 2. Now what is the removed node? It is temp dot get next. Okay, that's what I have done here in line number 73. Removed node equal to temp dot get next. Okay, so now temp is pointing to node 2, we know, and its next is pointing to node 3, which should not, because it is removed. Assuming that it should be removed and it is copied to removed, we will set this removed nodes next, or copy this removed node next to node 2, or where the temp is pointing. That is what we are doing in the 74. Temp dot set next. Temp is pointing to node 2. This set next value should be pointing to node 4. Earlier it was in node 3. So removed nodes next. Okay, get next or next will be point. Get next will give you the next reference. Okay, we'll copy this reference to this. Now this is pointing to this is copied to this, and this temp dot next is pointing to node 4, and we have to set this to null. By just copying this to this next is dereferenced to this removed node, and it points to new node, which is node 4, and we have to derefer this, as I told, by setting it to null. Okay, temp dot get next. Okay, temp dot get next is this. Temp dot get next dot set next equal to null. So this is set to null, and now this node is removed and node 2 is pointing to node 4, and if we call reposition, it will make this node 4 as node 3. Clear?
Yes, sir.
Any question?
Sir, after
Everybody?
74, still temp is pointing to node 2, no, sir?
Temp is pointing to node 2 only. Got it?
Can you explain 75 and 76? 75.
75. Temp is pointing to node 2. Okay.
Yes, sir.
Node 2's next is what? Node 3.
Yes, sir.
Node 3's next should be set to null. Got it?
Okay.
So even this is dereferenced, this is dereferenced, so that node 2 points to node. Clear?
Yes, sir. Got it.
Okay. So we have we saw even contains, get element. Only thing is, if you understand how to add element and how to traverse linked list, everything you will know. Okay, you should be able to traverse linked list by getting the temp and get next and get next. You should get all the data, and you should be knowing how to add. If you know add, the same way you remove. Okay, the same way you search. If you traverse data, in the same way you search, you remove, you do everything. Only thing is you should know how to add and how to traverse. If you know this, these are the core things. You know everything just by doing some permutations and combinations. Is this clear? This is a very important interview question. And if you tell that I know how to implement singly linked list in your resume, it gives some weightage to your resume. Clear?
Yes, sir. So a question, you're using that instance variable last just for easy addition at the end. Otherwise, it's not needed.
No.
Okay, sir.
But yeah, in another to get the last element, okay. Without head and tail, your linked list will not have what connection.
No, sir, only head and no tail.
How do you say this is the last node? How do you add an element to this linked list if you do not have information to this last node?
You traverse the array till you find that last dot next equal to null.
Yeah, you have to traverse, right? That requires more time.
Got it. Yes, sir.
Good. Now we will see what is Java linked list. Okay. So I also have this code. I thought of coding at least this, but we have already out of time. We'll just see the same methods that we saw with array list, guys. This also has same kind of methods. This is also imported from utils package, the java.util package. It is also inherited from the list interface. Okay, we'll create the object of linked list like this. This is called generics. We'll talk about this. Okay, and we have add method as we had in array list, and we have add method to a specific index by passing index and some element. Okay, and we'll create another list and we will add all. Okay, we will add all to one linked list, the another list, by doing add all, calling the add all method. How do you print the particular indexed element is by this, by doing get element. Okay, we have get and index of. Okay, it will search the element and returns the index, and we have is empty, and we have remove by using the value and remove by using the index. Okay, then I'm just going forward. Hope you all know this, right? Add. If you have done the first lab of collections, it is really easy to understand this. We have add method. Did you all test those methods?
Yes.
Yes, sir.
Okay. Okay, cool. Add method, get method, index of, is empty, remove. Okay, then size. Okay, we have size as same as that, converting it to an array. So linked list dot to array. Okay, it gives you an array. It worked fine for me. I don't know after that why it gave an error in the last class. You can search this, or you can just run this program. I send it to you today, and you have clear and you have size like this. Okay. Any questions? That is it. That is how linked list behaves in Java. I think linked list in Java. I have some write-up also here. Can go through this. I'll send all this zip documents. If we have add all, add accepts an element and also an index and an element. Add all accepts a collection and also an index and collection, which is an overloaded method. We have clear to clear the data out of the collection, contains to search whether this object is there or not, get particular element of that particular index, and index of searches the particular object and returns the index of that object. Is empty returns whether a collection is empty or not. Iterator we have, we'll talk about this iterator. Purposefully I've not taken this. Okay, then we have remove method. We saw how to remove method, remove an object, just remove and it will be removed. And we now know how internally the linked list works to remove, right?
Yes, sir.
Yeah, that is the power of knowing this data structures. Okay, removing is easy. You traverse, remove, add. You need not shift the data from their memory location. You create new data packet called as node. You traverse till that particular position, relink that. That's it. That's how remove works. That's how insert works. Okay. Then we have size. We have two array, two string. That's it. Internally, we just saw singly linked list. I did not take doubly linked list because it is still more confusing. Just first try to understand singly linked list in the same way as we have in node class, as we have next, we will have previous pointer. That's it. Okay. First code once or twice these methods of singly linked list. You implement it on your own. Okay, it's okay to see the code first, understand, and then implement on it your own. Then see, then try to implement the doubly linked list. Just add previous, and for that, the previous will have the connection with previous node. Okay, internally, Java uses the doubly linked list to implement these functions, these add, remove, contains, get, everything will works on the implementation of doubly linked list data structure. Okay. So as I told, accessing elements by index in a linked list is generally slower than in an array list because it requires traversing the list sequentially. Linked list is a good choice when you frequently need to insert or remove elements in the middle of the list, but not when you primarily perform indexed based operation. Means the main thing is the random access. Index helps you mainly with the random access. Array of 1 takes same time. Array of 1 lakh also takes same time. It's same time to fetch the first box of array, and it's same time to fetch the 1 lakh positioned box of the array, but not the same case with linked list. To fetch the first element, you can just fetch the head. To fetch the middle where 50,000, you have to traverse through all the 50,000 nodes to fetch that. Okay, that is not the intention for which linked list is used. If you have that kind of operation, it's better to use what data structure?
Array list.
Array list, correct. So unlike array list, which uses array internally to store element, linked list uses nodes to create a doubly linked list. This allows for efficient insertion and deletion operations, especially in the middle of the list. Okay, it's not synchronized. We'll understand what is synchronized and not synchronized, everything when we learn multi-threading. That topic is pending. We'll learn that. Okay, and that's it. Any questions?
Sir, please share this code immediately after the class, sir.
Yeah, sure. I'll do that. No questions? I think I had told this one quote from Sanskrit. I'll end the session by telling that Udyamena hi siddhyanti karyani. This is just to tell that there is a lion and no deer comes and enters the lion's mouth until and unless it goes for hunting. It is just its hunting will get its food. In the same way, just by wishing that I should have some food, I should have some job. Udyamena hi siddhyanti karyani nahi manorathaihi nahi pravishanti nahi suptasya simhasya pravishanti mukhe mrigaha. No deer will come and enter the lion's mouth when it is sleeping. When it just goes for hunting and works for hunting, then only it will get its food. Just by having mere wish will not get you anything. You should work for that. So I'm not seeing you people working as I expected. You're not giving any much of response. Please respond in the class so that we understand where you are. Okay, so that we understand what to do or how can we help you people. Okay, if you do not want to work, we cannot help you. Okay, please work with positive spirit. We do not know when the market opens up. We do not know when companies come up and hire you. But if we stop learning, if we do not learn, then nobody will hire you at any point of time. But there is a certainty that at some point of time, companies will come up and market will open. If you do not learn, if you do not upskill yourself, or if you do not what do they say? If you do not equipped with the skills that market needs, then nobody will hire you. We can upskill ourselves, we can update ourselves, we can equip ourselves, whatever skill is needed and whatever we think to be, nobody can stop us. If we have those skills, market will certainly take us whenever it is open. Okay, this is what I wanted to tell you. Vikram sir is trying to get you companies. He's trying very hard, even in this worst situation. So be equipped with the skills. That's what I wanted to tell. Okay, guys. Thank you. Thank you for the patience of 1.5 hours listening me to this difficult topic of implementing linked list. It's easy only if you imagine, if you think what's happening. You should think how much ever one may explain, but you should think in coding what's happening. Okay, you should have some mental picture, then only it becomes easy. It's not so difficult. So please go through the videos also. It will give videos of Vikram sir in the portal. It will give you much clarity. Okay, please go through that and work. Thank you, guys. Bye.
Okay, see you soon.